Hi, I'm Rahul. In this video, me and my team members will be explaining about the project that we did as a part of ECE561 course. The title of the project is Low Power Wearable Activity Monitoring System using IoT Interface. Now, I'll begin this demo by explaining the wearable interface. Basically, we have used a cardboard and duct tape to provide a casing for this prototype. A firm bubble wrap has been provided for the prototype so that it won't be shaky when the user wears it. As you can see, there is also a rubber band provided to it so that it provides additional firm support which the board needs. Now this is the battery interface which we will be using. The reason to choose such a small battery is it shouldn't add any extra weight to the user. So while the user wears it, that's the main reason we chose it. So if you look close into the prototype, so this is the house which holds a battery. I can just insert the battery into it. So and this is the place where the user puts a belt into it. Now let me show how to put the belt into it. As you can see, as you can see now the belt is inserted into the prototype, so the user can wear it whenever he or she wants. So now we go into the working part of it. Now I'm going to power it up. As you can see in the home screen, it's asking us to set the goals. The goals can be set by pressing these two buttons. This button is to decrease the goals and this button is to increase the goals. Once we set the goal, we have to start the pedometer by pressing this button S2. As you can see, the goal has been set at 4 and it's setting up to connect with the Wi-Fi. The blue light indicates the working of Wi-Fi booster back. So now the device is ready. So once we press button 2, the pedometer will start to track the activity. So
Hi, my name is Vinesh. I'll be continuing with the demo, and I'll now demonstrate how the code resets the board, and on reset what appears on the summary information. So now I'll press the start button here, and as you can see that the step walked information was 0 and the progress was 0 percentage. Let me demonstrate one more time. And the summary information is available only on demand. So the code is now running in the background, and every time I try to activate the pedometer, you can see that the steps walked increases, and it happens in the background, and the we display only the information for 2 seconds whenever we need on demand by the user. And one more thing I want to mention here is the percentage goal and the steps walk goal is updated uh, on real time by the automatically when the user uh, is in an activity. Thanks.
Hello, I'm Shadab, and I'll be going over the IoT interface for the Perometer application. So I have the device here in my hand, and I'll just go ahead and start the activity, and we can see the timestamp appear in the debug console. So there, it started the activity, and the progress is at 0. So I'll just try to finish the activity by just like shaking the device. So we can see as we progress, I mean, it posts the timestamp and the percentage of the progress. So when the activity is completed, the debug console posts the time when it was completed as well as the progress. And this is basically the summary for the session. So from the IoT, we can also update the number of steps that are the goal for the activity, and currently I have it set at 10. So I'll just go ahead and we can see that the goal has been updated to 10 steps. It's kind of difficult to show over here. So the IoT interface can be used to update the number of steps this way, and my teammate will continue with the
Hello, my name is Akshay and welcome to the demonstration for the final project of EC561. Let us continue on with the demonstration. Okay, so now I've switched on the pedometer and it's running currently, but the LCD display, as you can see, the LCD display is currently off. So what we have done here is we have switched off the backlight when the pedometer is running, and only on demand we can see the current summary or the statistics of the current situation. So this has been done to reduce power consumed by our device. So the LCD backlight consumes a lot of power, and this is our way of reducing the overall power consumed by this device to hide the display whenever it's not necessary. So now we can see that the pedometer is running and currently some statistics are shown, and if something happens and the power to the device is cut off, we can see that the goal is still being retained by the permanent memory, and that is being retrieved here. The user may change it here again or continue if he wishes to. Again here, as you can see, I must have shaken it. We can see the steps counted till now is also being preserved in the permanent memory. So this way, due to some unfortunate incident, if power to the device is cut off, we can see that the data is still being maintained. So now I've simulated a few more steps, and we can see that once the goal of 4 steps have been reached, we can see the display of goal reach being shown for about a couple seconds again and then vanish, and we can hear the buzzer being played. So yeah, this is a demonstration for our project. Thank you for watching. And one more thing is, along with this demonstration, this demo video, we are also submitting the login details for our IBM Bluemix account. So if you need to log in and check out the database of all the received messages there, you can do that. Thanks again.